hear me breathing through my nose. So yeah, I work at SoundCloud, which is based in Berlin, which is where I'm also based, and my name is Tiffany. Oh yeah, I do need to catch my breath. Whew, it's bigger than you think. Yeah, my name is Theophany Online, and today is the best day of the rest of my life, because I know with confidence that I will never have as bad a hair day as this. Yeah, so I work at SoundCloud. My specialty is designing web-based tools, especially tools used by the operational staff. So at SoundCloud, for example, I build and design the user administration system, so things you haven't seen. And before that, I worked on a customer relations management system for a bank and a few other content management systems. And I'm here today to talk about user capabilities, meaning the things that people can't do, but more importantly, I think it's the things capabilities are things you can do, but more importantly, it's about things they can't do. And I think in your career, whether you're strictly a developer or also a designer, you're going to come up against this in your career at some point, if not already. And this is especially true for someone like myself who builds tools, but this I can imagine extending to you for other reasons. So for example, in a WordPress blog theme, only the blog owner should see the edit link, and only when they're signed in. Premium users of your product, maybe they only should get access to special features. And in the type of applications I build, only supervisors should be able to edit, for instance, product categories in an online shop. So, in my own work, this is a screenshot from the system I build, and I'm continuously adding new features, many of which should only be accessible by authorized people. And so when I wanted to introduce access restrictions into this application, I went on a hunt for existing approaches for handling user access restrictions, and I've gathered some of my findings to share with you. And I've divided the talk into two parts. Part 1, the UX of user capabilities, and Part 2, implementing user capabilities. So let's get into it. Part 1. From a UX perspective, why you should care about this. You should care about this because good user capability UX helps people to avoid mistakes, understand what their capabilities are, and easily manage permissions. Specifically, let's look at good user capability UX helps people avoid mistakes. First of all, let me just ask this rather obvious question. Why add user access restrictions to a system anyway? Obvious answer. People should not be allowed to do things they are not allowed to do. Should they not be able to do things? So this might seem super obvious, but when you look at human societies, there are lots of examples of where we don't actually prevent people from doing things they should not do. We just tell them not to do it and trust that they won't. And in computer environments, we don't have to trust people. We can actually restrict their access. And this sort of implies that we don't trust them. However, there's another concept that came out of the 1970s, and that is people should not be able to do things they do not need to do, which isn't about trust. And this is known as the principle of least privilege. And the principle states that an agent must only be able to access information and resources that are legitimately required for its purpose. So if you apply that to people, the principle translates to giving people the lowest possible rights that they need to get done what they need to do and nothing more. So when you follow this principle, you limit the potential damage of any security breach, either accidental or malicious. And while this is good for data integrity and other faults, I think it's actually also good UX. You shouldn't allow people to do things they shouldn't do and then somehow punish them for it. So when you follow this principle for protecting data, you also get a better user experience, which leads me to my next point. Good user capability UX helps people understand what their capabilities are. So for me, this idea follows directly from basic considerations of interaction design, which are user interaction design asks, how does the user affect change? How do they understand that change? And how do they understand what they can change? And this last point is exactly what I'm getting at, which is that the user needs to understand what they're capable of doing. So your UI must communicate what the person can do, but this isn't as important, again, as your UI must not communicate that the person can do something they can't, because that would be extremely frustrating. So it's vital that a UI reflect what the capabilities are and don't give the wrong impression, because that would be poor UX. Now, there are a few exceptions to this. So for example, you might have an affordance like a button, which looks like it should give you access to a feature. And when you do interact with it, it tells you explicitly what you need to do to have the ability to do that. So it might be a feature which you can only get with an upgrade. So it would tell you, hey, you might want to upgrade to do this. Or in the case of my software, it might say, hey, this is a feature which only these type of people have. Talk to your supervisor to get permission if you think you need to do it. So my last point about capability UX is that it helps people to easily manage permissions. And what I'm talking about here is, if you're like me, you don't just build the interface which needs to have access restricted, but you also need to build the interface to manage those permissions. And the good news is you don't have to invent an approach for this because they already exist. And I mean, you can invent an approach, but you may want to know that there are existing ideas in this realm. So just for some definitions, because there's a whole vocabulary for this, and knowing the terms is useful, but it also clarifies the concepts. So I already talked about the principle of least privilege, and now I'm going to discuss some other terminology, and then I'm going to talk about the two most widely known approaches for managing access restrictions. So the things I'm going to talk about are subject, object, operation, and permission and capability. So subject is an active entity, such as a user or process. An object is a thing that the subject acts upon. An operation is the action attempted by the subject on the object. Permission is the right to perform the operation. And capabilities, then, are those allowed operations that the subject has permission to perform on an object. And more simply, what I'm talking about is I'm going to limit my discussion to people having the capability to perform actions on things. And now I'm going to explain the two most widely known, most widely used approaches for managing permissions. And we're specifically here looking for which one has better UX. And these two things are access control lists and role-based access control. So an access control list is a list of permissions for an object, and typically each entry specifies the subject and the operation for the object. So an access control list is a list of people who can perform actions on a given thing. So for example, the access control list for products might be Alice can view the products, Alice can edit the products, and Bob can view the products. Now, when I introduced access restrictions into the system I build, I had to choose which one. And I wanted to pick one that would be easy for onboarding people onto the system, so a non-programmer would have to go in and decide what permissions someone would get. And this can become very tedious with an access control list. So let me just walk through an example. Imagine you work in a warehouse, and you have just hired a new junior warehouse clerk. And the clerk's job will be to add incoming orders to the system, and they will check incoming orders before they leave the building, and they might edit orders as well. And your job is to add this person to the order management system. And you're going to get a list of operations per object, and it's going to look something like this. So how do you know which actions to allow on which things? You would need to understand the job of the warehouse clerk. You would need to understand the sorts of things they do in order to just update this list. And this is a junior warehouse clerk, and they're not going to be able to do the same things as a standard clerk. And what if it turns out that one day a week this person is a sales rep, and so on those days they need permissions that the junior warehouse clerk doesn't have, but the sales rep needs? And this approach just isn't manageable, and it's hard to understand. And what if you needed to update such a list? You would have to have a separate list of people who worked as a junior warehouse clerk, and if you added a new feature to your application, you'd have to find this list of people, you'd have to go into their settings, and you'd have to update that permissions on the object level. This is gross. So this is a random example I pulled from the internet, and it's from a site explaining how to grant permissions in SharePoint. This is not good UX. This is the rest of the web page where I pulled this example from. You don't need to read it, ever. There's a saying that says that a user interface is like a joke. If you have to explain it, it isn't very good. So you might be thinking, what about permission groups? And that approach, that brings me to the next approach, which is role-based access control to the rescue. So role-based access control is, instead of granting each person a laundry list of possible changing capabilities, you instead think in terms of the roles that exist within an organization. So a role then is a job function in an organization, but more generally a role is just a collection of capabilities. And these capabilities help you complete perhaps interconnecting processes. And the permission to perform a certain operation is assigned to a role, and a single capability can be assigned to multiple roles. People can have more than one role. And all of these role assignments grant the person the capability to do things in order to perform what they need to do in the system. And that way, whenever a role is changed, the person's capabilities are automatically changed too, by extension. So when you have this approach, when you grant permission, you only need to understand the role that the person will do, because all of the thought about what does that role entail happens up front as part of a design and development process of new features. So, role-based access control or access control lists, well, bad UX leads to mistakes, and we saw that access control lists were hard to manage because they had poor UX. And when the UX for managing permissions requires some implicit knowledge, people are going to make mistakes, and mistakes can lead to violations of the principle of least privilege. So, role-based access control is better UX than access control lists. So, quick recap. Good user capability UX helps people to avoid mistakes, understand their capabilities, and easily manage permissions. You can avoid mistakes by following the principle of least privilege. People should be able to understand their capabilities because your UI communicates it to them. And you can easily manage permissions if you use role-based access control. All right, part 2, implementing user capabilities. But first, my assumptions. Second, a drink. Okay, so we're talking about implementing in a client-side rendered app that uses REST APIs to load and save data asynchronously, and the server can tell the client details about the authenticated user. And although these ideas can apply to server-side rendered views as well. So we saw, directly following from the conclusions about UX, we have these constraints. You should only grant necessary capabilities, your UI must communicate those capabilities, and you should use role-based access control. And I also had an additional constraint when it comes to implementation. So this one is so fundamental, I will number it 0. The server must enforce the restrictions. I think this is pretty obvious to everyone. We all know how easy it is to circumvent your web UI. Not only can you use curl, you can just edit the UI directly. So obviously, your server must be the authority on what access rights the user has. The server side must enforce the restrictions, and the client side must reflect those restrictions. Now, this conclusion, or this implicit understanding, made me very worried that I was going to have to duplicate logic in multiple places in both the server and the client code, and I wanted to find a way to make this as simple as possible, and I knew I wanted to avoid logic like this. So, in this example, you have if they're the junior warehouse clerk, if they have those roles, or they're the warehouse clerk, or they're the warehouse manager, then do something. But with this approach, you are effectively defining which roles have which capabilities, which is the whole point of having roles and capabilities. So all of the logic that a junior warehouse clerk can view orders is already implemented somewhere else, and all you need to refer to here is the actual capability of viewing orders. So since the authority is the server, you need to be able to ask the server, what capabilities does this person have? What capabilities does the authenticated user have? Or the server could somehow proactively provide that in scope. So if you needed to, you could implement something like this, where you specifically ask, give me the capabilities of the authenticated user. If you wanted this to stay current, because your app never refreshes, you're going to have to develop a strategy for doing that. But for the most part, capabilities don't change very often. Maybe if the person's fired, they haven't been told. They might click on a button and told they're not able to do it. But obviously, these sorts of things don't change so often, and as long as the server is the authority, you're in the clear. So this snippet showed the checking for one capability, but what if your UI element is a little more complicated? I know it doesn't look complicated, but maybe this UI element is this little button, and it exposes this menu. And for each one of these items, you need a different capability. And if the person can't do any of these things, you don't even want to show this button at all. So you can check for whether or not they have view orders in their capabilities, editing orders, and managing customers, and only then show the dropdown. And because this is always going to be additive, because by definition a capability is something you need, that was crazy, boom. Because a capability is something that you need, it's always going to be additive. So it would be sort of convenient then if we had something like this, a method that would take a user and a list of capabilities and return true if they have any of them. And here's just a little implementation of the can function. You could obviously do it differently if you wanted. So this is now possible to use. You can say, can the user do something? And you would get back true or false. And can the user do action 1 and action 2? Then you would also get true if they could do either one of them. So what about logic list templates? Just a show of hands who uses Mustache or has used Mustache. Yeah. So this will not be super unfamiliar. In your view code, you could then pass in the user capabilities as a view variable, and then you could use it in this way. And this does get more intense if you have more than one capability that you're checking. And for example, this is the menu that we described. So we have one item is can view orders, the other is can create orders, and if the person can't do either one of those things, you don't want to show this at all. This doesn't work because this is additive. You were saying if, then inside, so you would never get to the inside if they could not view orders. So one way you can do that is you can augment the user's capabilities with the view-specific ones before you pass them into the Mustache method. And then you would get something like this, which is view-specific and so not sort of inappropriate. Now, I don't actually use handlebars, but who does? You'd use handlebars instead of Mustache. So you can do something in handlebars, which means you don't have to do this in the other code. You can have a block helper, which takes maybe a space-delimited collection of the capabilities, and then you can pull those out, check if they have some capabilities, and then process the block normally. And then you'd have something like this where instead of using the attributes directly, you'd use this can block to get that checking done before you keep going in. Now, you can use the same sort of idea of having this can checking on the server side. I use a Sinatra backend to proxy all of the calls that we make to the different APIs. And so, on this way, I can actually broker and block on the route level. And that way, you have the sort of same concepts existing there. And I usually map the routes to a capability. Potentially 2 routes require the same capability, but normally a route doesn't require more than 1. So in conclusion, we had these implementation constraints, which were only grant necessary capabilities. The UI must communicate capabilities and use role-based access control. And that led us to these considerations when we're implementing, which is that you need to enforce in both the server and the client, but you should make the server the authority. And 2, you should check against capabilities and not roles. So thank you.